In the last video, we saw how acetylcholine release at the neuromuscular junction caused a graded membrane depolarization. Today, we're going to look at how the graded depolarization leads to muscle contraction. This process is called excitation-contraction coupling. If you want to review the different types of ion channels before we start, you can find the link to that video in the document that's linked up there to the left. Look in the section on cell biology. To start, I'll draw a skeletal muscle fiber. We see the plasma membrane or sarcolemma, which has acetylcholine receptors at the motor end plate. As we move further away from the motor end plate, instead of acetylcholine receptors, we see voltage-gated sodium channels. These open when voltage inside the cell reaches a certain threshold, which is called, conveniently enough, the threshold voltage. That voltage is about a negative 55 millivolts. We'll use that number coming up. Moving further along the sarcolemma, we find deep invaginations called T-tubules. There we're going to find another type of voltage-sensitive protein, and it's attached to the sarcoplasmic reticulum. Sarcoplasmic reticulum is a fancy name for the endoplasmic reticulum of the muscle fiber, because anatomists need lots of complicated words. The sarcoplasmic reticulum contains lots of calcium, and there's a strong electrochemical gradient driving calcium from the SR into the sarcoplasm. Pumps are always using ATP to return calcium to where it wants to live when the cell is at rest. The skeletal muscle fiber rests at about a negative 85 millivolts. When acetylcholine receptors open, sodium enters the cell, causing it to become more positive. The more receptors that open, the more positive the cell gets. When the cell reaches a negative 55 millivolts, the threshold voltage, voltage-gated sodium channels begin to open. This is a positive feedback loop where sodium entering one channel opens the neighboring voltage-gated channels. This forces all the channels along the membrane to open in a wave of depolarization. The wave of depolarization is called an action potential. All action potentials are the same size because every voltage-gated channel opens once the process begins. As the action potential travels down the T-tubule, it causes a change in shape in this voltage-sensitive protein. That causes calcium to be released from the SR. The calcium floods the sarcoplasm surrounding the myofilaments and binds to a thin filament protein called troponin. Calcium binding to troponin causes the myosin binding sites on the thin filament to be exposed. Remember that myosin is a motor protein in the thick filament that uses energy from ATP to grab the thin filament and move it towards the center of the sarcomere. This shortens the sarcomere, which shortens the myofilament, which shortens the muscle organ. The process linking the electrical change at the motor end plate to contraction is called excitation-contraction coupling. In the next video, we're going to look more closely at how calcium binding to troponin causes muscle contraction.